All right, you guys, second to last chapter. This is super exciting. Sequences and series. Depending on what level of Algebra 2 you were in last year, you may have seen this stuff before. Here's the good news about this chapter. It is very, very formula heavy. So I know a lot of you guys are formula people where you just want a formula, plug in your numbers and get the answer. This is a lot less abstract, I guess. It's a lot more straightforward than like the probability chapter we just finished, where each question was like kind of a little bit different. So hopefully that's a good news point for a lot of you guys, but I've got a little bit of vocab for you. I want to talk first about what an arithmetic sequence is. It's a pattern like a group of numbers looks like this, separated by commas that have a common difference. We refer to that as D, and that D goes in the formula. And so the difference here, I'm going to zoom in a little bit so you can see this. The first example is 1, 5, 9, 13. It continues like that. And all you have to do is figure out what you're adding or subtracting. The numbers could be going down each time. And in this case, the D is 4. And there's a formula for it. And I need to make sure that you're okay with this like notation. But this is A sub n, and it means the nth term. So if I made this A sub 13, that would mean the 13th term. Or if it was A sub 1, that means the first term. So whatever that little subscript number is means the term number. And so this is the first term. This is the actual number of the term, like it would be a 1 for the first term, a 2 for the second term, a 3 for the third term, whatever. And then the D is the common difference. So we'll practice using this formula once we do a couple examples in just a second. But we also have this thing called arithmetic mean. And it's terms in between any two non-consecutive terms in an arithmetic sequence. So again, we have an arithmetic sequence. Here's a different example. You can tell you're just going up by 11 each time. But if we look at these two numbers, 27 and 38, those would be referred to as arithmetic means in between 16 and 49. All four of these numbers are arithmetic means in between 5 and 60. So there could be more than two of them. It just depends, and we'll do a couple examples that look like that as well. So I want to start by talking about this formula. Let's go right into the very first example. It says write a rule for the nth term. So the first thing you're going to want to do is figure out what are we adding each time. It looks like we're adding 5 each time. And that's what makes this an arithmetic sequence. FYI, a little bit later in the chapter, if you're multiplying by a certain number to get each next term, that's a geometric sequence. We'll get to that later. These are arithmetic, and so since I'm adding 5 each time, that means that my D is 5. If we were subtracting 5 each time, the D would be negative, okay? I'm going to use my formula. A sub n just means the nth term equals A sub 1, which is the first term, plus n minus 1 D. And what I'm going to do is I'm going to plug in the 5 for D, and I'm going to plug in the 4, which is the first term, for A sub 1. Okay, so that means that if I want to find any term, A sub n, my formula is 4 plus n minus 1 times 5. And yes, I can clean that up a little bit. It's 4 plus 5n minus 5. And so that means my formula for A sub n is 5n minus 1. And so then if you read the directions up here, it says write the rule. This is the rule. If I want to find the 15th term, which is the second part of the directions, that means if I want to know if I would write out all of these numbers 15 times, which I don't really want to write out 15 numbers. It's faster to use the formula. If you want to find A sub 15, which means the 15th term, that means you just plug in 15 for n. Okay, so the 15th term happens to be 75 minus 1, which is 74. That means if you would write out this entire sequence and you would write it out 15 numbers, the 15th number way out here would be 74. Much faster to use the formula. What if I wanted the 115th term? You just plug in 115 right there. Okay, let's try another one. In this case, we have a difference that is negative. It looks like I'm subtracting 8 each time. That means my D is negative 8. Again, I'm going to go with the formula. A sub n equals A sub 1 plus n minus 1 times D. and I'm going to plug in the -8 for the D, and I'm going to plug in the 6 for the A1. 6 plus n minus 1 times -8. Be careful when you're distributing that -8. That gives you a rule of 6 minus 8n positive 8. That means I get -8n plus 14 for my rule. And again, if I want to figure out the 15th term, I'm just plugging in 15 for n. And that just gives me, for the 15th term, -106. So again, it should kind of be a little bit of common sense. You know these numbers are going down and getting bigger and bigger negative-wise, so 106 being negative makes sense, just so that we don't like make a silly mistake with our signs, so be aware of that. Okay, this one, go ahead and pause the video. I'm going to work it out and just check your answer. So here I've got my formula. So we're adding 1/2 each time, so my D is 1/2. You can leave it as 1/2, or you can put 0.5, whatever you're more comfortable with. Here's the formula we start off with, and I replaced my 1/2 for my D, and I put my -1/2, which is my first term, in for A sub 1. Remember that little 1 there means the first term. And the rule for any term that I want to find, I could find the 100th term if I want to. That's why we leave it as A sub n. That's what it's equal to, because you can change n into whatever term number you want to find. So again, if I want to find the 15th term, all you have to do is plug in 15 there and you get 6.5. Okay, I've got one other one for us to try along these same lines, and that's this one, number 2. It says find the 100th term. And so again, these are counting down. We are subtracting 1/3 each time. So that means my D is -1/3, and I'm going to use my formula again. So I'm going to start with my A sub n equals A sub 1 plus n minus 1 times D. And I'm going to plug in the A sub 1, which is 9. Remember, that's the first term in the sequence, so that's what goes first, plus n minus 1, and the D was -1/3. So I'm going to distribute that -1/3. And that's going to give me A sub n equals 9 plus 1/3 is 9 1/3 minus 1/3 n. That's my rule. And again, what I need to do here is it wants the 100th term. So that means that A 100 equals 9 1/3 minus 1/3 times 100. You can find any term number you want. I definitely do not want to write these out 100 times. That would take forever. So we're using the formula here. And we get 9 1/3 minus 33 1/3, which gives you -24. Ended up being a nice whole number. Okay, I am going to skip 3, 4, and 5. I want to do those together in class. They're a little bit harder. You're welcome to give those a try, but it's still just using the same formula. But I want to save those as a warm-up for tomorrow. And I want to talk a little bit about arithmetic means before we end. And so this first one says find 2 arithmetic means. All that means is 2 spots in between -7 and 8. And if it's an arithmetic means, that means that you're either adding or subtracting the same number each time. So I'm going to put -7, comma, something, comma, something, comma, 8. That's what 2 arithmetic means means. You're putting 2 slots in the middle. And then remember, the way that we come up with these sequences is we add D each time. And so I'm going to write a formula out of this. My first number is -7, and I have to add 3 different D's. I'm adding D to get this slot, I'm adding another D to get this slot, and I'm adding another D to get 8. So 7 plus 3D equals 8. And so again, all I'm doing is I'm starting with my first number, and I have to add D 3 times to get to 8. And so there's the formula that I'm writing. So all you have to do is solve that. You end up with 3D equals 15. So that means that D equals 5. Okay, cool. So if I'm adding 5 each time, that means that this spot is -2 and this spot is 3. And a way to check to make sure your answer is right is you should be able to figure out like the pattern here. We're adding 5, adding 5, adding 5, and it works out perfectly. Okay. The next one, very similar, 3 arithmetic means, which means 3 spots in between 3 and 9. So I'm going to write 3, comma, spot, comma, spot, comma, spot, comma, 9. And again, what I'm doing is I'm adding D each time to get my next spot. So in this case, since there's 3 slots I need to fill in, that's actually 4 Ds. So I'm starting with 3, and I'm adding D 4 times, and I'm ending with 9. So again, first number plus D plus D plus D plus D equals 9. So it's adding 4D. So when I subtract 3, I get 6. D equals 3 over 2. Okay, so again, now all I have to do is fill in my spots. 3 over 2 is the same as 1.5. So 3 plus 1.5 is 4.5, plus another 1.5 is 6, plus 1.5 is 7.5, plus 1.5 is 9. Again, and this increment every single time is 1.5. Okay, you guys, so that's your intro to arithmetic means and arithmetic sequences. So a couple things just to remember. Arithmetic means you're either adding or subtracting something every time. And make sure you got that formula, because if you're good with the formula, you should be able to do any number of problems that I throw at you, okay? Thanks for watching, you guys. Have a great night.